Hi. My name is Thomas, as already mentioned, and in the next 20 minutes or so, I'll try to tell you about the experience MobilePay had with event sourcing. So let's start with a quick agenda on how we're actually going to spend those minutes. So first of all, I'm going to do a shameless plug for the company that is nice enough to pay me overtime for doing this. From there on, we'll move to the basic theory behind event sourcing. We'll also touch upon the benefits that we gain. And of course, there's no free lunch, so we'll mention quickly about the downsides that we have to deal with. Towards the end, I will come to the interesting part, in my opinion. We'll talk a bit about the mistakes that we've made along the way. And I'll do my best to leave some time for your questions. Good, so let's move on to the shameless plug. You can see right here MobilePay's logo on what used to be Danske's head office. There are historical reasons for this. MobilePay started as a teenager son of Danske Bank, so we lived out of their pocket. Not so long ago, we actually managed to cut the connection, and today when I was coming to an event, I actually, just like you, had to get escorted inside by a security guard. So given the history, I guess it's no surprise that we're actually doing mobile payments. This can also be inferred from the name to some degree. When it comes to our user base, we are market dominant in Denmark, where we have, I would say, 19 out of 20 phones in the country have the applications installed. And we also have pretty strong market position in Finland as well. Every day, we do roughly 2 million transactions come together in both of these countries. And why I'm mentioning this, like event sourcing might sound not practical if you haven't done it before. So I just want to make sure you understand it's production viable. When it comes to engineering, there's roughly 100 of us. We're somewhat equally split between Denmark and Lithuania. As pretty much any other hip, cool company these days, we do microservices, of which we have, I would say, somewhere between 100 and 150. And what I believe really sets us apart from the competition is that we have been doing event sourcing for almost 7 years now. So at the very least, when it comes to failures, we know what we're talking about. But, oh yeah, there's also me. My name is Tomas Bingelis. I've been doing software for 12 years now. Started as a software engineer, and then went on to become engineering manager. And I'm currently holding the role of an architect. In reality, I don't think these titles matter that much. Like, the way I see myself is a bit of a jack of all trades, as in, you pay me money and I'll do stuff for you. Okay, so when preparing for this talk, the first thing I did, I actually went on the internet and researched what event sourcing is, not surprisingly. That was mainly because I wanted whatever I tell you guys not to contradict entirely with what you can read in other resources. I think I agree with most of the things I've seen, but there is one thing in those articles that really bothers me. I think a lot of the articles I've read tend to piggyback a lot of different patterns under the name of event sourcing. What it really is, it raises the bar for entrance that much higher, and if you're just contemplating on possibly starting event sourcing, well, you might be deterred by the complexity. So right here, you can see most of the main patterns that MobilePay's reference architecture uses. Right? There's DDD, which is technically not a pattern, but more like a technique for domain discovery. We do that. There's event-based or event-driven, which is essentially an architectural pattern for sharing data across applications. We do that as well. There's CQRS, which allows us for easier scaling of our applications, and we, of course, do that also. However, we have an event sourcing here in the center, and all of these green triangles, while nice, and they complement event sourcing in many ways, they're really optional, and if you're just looking to start, it's completely viable to do just event sourcing alone. So for the purposes of this talk, and also for the purposes of keeping it somewhat brief, we will only talk about event sourcing today. Good, so what then is event sourcing? Well, first of all, it's a persistent pattern, so it has nothing to do with messaging solutions. It's the first misconception I wanted to clear. And with that out of the way, I think event sourcing can be pretty well summed up with these two sentences. So first of all, we always persist only changes to our process and not the current state. And then secondly, we, like our own miniature communist Chinese state, we never forget things. So we hoard data, we never delete it, we never modify it. The only way to make changes in our system is actually writing a new entry. I think at this point, it probably makes sense to illustrate with an example, and I took a very cookie cutter one. So let's say we have an application that allows users to be onboarded and keeps their contact details. So at first, let's explore the scenario in the traditional CRUD application. We see we have a user, Peter. He onboarded, but he did not provide any of his contact details for us. Maybe in a while, if we're nice and he likes us, he will share his phone number with us. We'll store it, and things will move on from there. Then some more time passes, and we do the same with the email. We also store it. Now time goes on. Peter enjoys our app, but unfortunately, he had to switch phone carriers. And at this point, typically, you get a new phone number as well. So what we do, we will store the phone number, and that's pretty much it, right? At this point, if I were to ask any of you what was the previous number for Peter, I don't think I could get a straight answer. Furthermore, if I were to actually ask a person that isn't in the audience right now, right, they would be oblivious to the fact that Peter ever switched phone numbers. So this is the part that event sourcing, at least one of the things that event sourcing aims to improve. So let's take a look at how the same scenario would look in an event-sourced world. So we start with a single entry that states user was created. It's pretty much similar to what we had before. There's an ID, there's a name. Then in some time, we get a phone number for Peter, which is a new entry in our database. It states that phone number has changed, and that's the phone number that Peter now has associated. Once again, we do a pretty similar thing with an email. We have an event for that as well. And finally, once Peter switches carriers, we store the new number as well. There's a couple of things worth noticing here. So first of all, the size of our data, it keeps growing ad infinitum, right? So we're just adding new entries. Secondly, this is where the data loss free part comes in, as in we have both of Peter's numbers and know exactly when they changed. So if I was just to tell you about the very basics of event sourcing, I think we could pretty much wrap it up here, but I see the beers haven't been delivered yet, so we can spend like 10 more minutes taking a bit of a deeper look. So what the hell is this really? Each entry in event stored database, each entry in event source database is called an event. And a single event is a representation of action that already took place in our business domain. Let's quickly go through the properties. So there is stream ID, and one of the largest problems is that in your production database you'll have millions of events, and it's kind of hard to correlate between them. What stream ID does, it organizes those events into what's called event streams. An event stream is typically a model of a certain business object in your domain. So in our case, an event represents everything that ever happened to a particular user. In a traditional application, you can think of stream ID as of user ID in this example. Moving on, there's sequence. And what sequence does, it uniquely identifies order of events inside a single stream. So assuming we have all the events happening in the same stream, we know that an event phone number changed with the sequence 1 happened prior to an event email changed with the sequence 2. However, after the event with the sequence 0. From there on, there's event type or event name, depending on the literature that you use. And what it really is, it's just a human-readable name for what happened. Ideally, it would also hold some value for your subject matter experts. Now, data field is a bit different. You might have noticed it doesn't have a strong schema. That's because for different types of events, different sort of properties are relevant. That doesn't really matter how you implement it, and depends a lot on the storage technology that you use. But the important part, it's supposed to be dynamic. Last of all, there's timestamp, and it's somewhat self-explanatory. It tells us when exactly did the event take place. So we already spoke, and now we know how our user data is structured in an event-sourced system. And in comes an evil PO and tells that he needs a current state because UI needs to be rendered. So what do? there is a technique called projection, and in a nutshell what it is, we just take all the event stream and apply it in order of sequence one by one onto an empty model. Once again, I think it's best if we illustrate it with a small example. So we start with an empty model of the user, and we take events in order of sequence one by one. First event we had was user created, and it contained ID as well as the name. So we added it to our model. Further on, there's phone number. We add it as well. Now we have phone number in our model. We go on with an email, and here's an email in our model. So at this point in time, you might believe that this is a model that we want. While this is partially true, it's not exactly. This model right now represents Peter as he was as of January 8, 2315. What this is called, it's called a partial projection, and it allows us to query data as it looked like in the past. What we really need, or what we were requested, is the latest state. To obtain that, we still keep going through all the events until the entire stream is read. So in this case, we still have phone number change, and we overwrite it in our model. Yep, there it is. So this is the state that we would use to render our UI. In practice, there's two types of projections that I'm aware of. What I just showed you is called an in-memory projection, and it's typically processed on request. There is an optimization that you could do. It's what's called a pre-computed projection. So based on a cron schedule, or if you're doing event-driven, maybe live as new events arrive, you would be calculating these projections and store them in a special state table, which you could then use to serve the UI. Okay, the last thing I wanted to mention about the projections, we don't really place any locks on any of our tables. What it means in practice, all of these are stale by definitions, just like your regular API calls. Good, so we talked about reading, we talked about storing, the only thing remaining is actually writing. And for this we have something called a write model, or depending on the literature, you might also read the name aggregate. In essence, it's very similar to projection, or it starts similar to projection. So you can see we also have the name, phone, email, all the properties you might need, right? These are also obtained by replaying existing events in our stream. From there on, we also need to be able to accept requests for doing changes to our model. So it sounds fancy. What it is, we have a method. Change email, new email. Pretty simple. One of the things that is up to write models to do is actually ensuring that our domain model is consistent according to the business rules. So I couldn't come up with a really nice example, so you'll have to do with the best I could. Let's say our PO doesn't want a non-empty email to be replaced by an empty one. Technically, it's almost loss of data, right? So it's up to our write model to do the validations, throw an exception to stop this from ever happening. And the last thing remaining is we actually have to be able to emit new events in case validations pass, and we're happy with the result. Whether it's one event or many events, doesn't really matter. We can do that in write model also. So this part sort of sums up the theoretical part I had for you, and now I'm moving on to what I think MobilePay is gaining from using event sourced. So first of all, it's way easier to do debugging, and most of our troubleshooting sessions don't ever have to rely on reading logs. That's because whatever ever happened to our business entities, those things are actually part of our source of truth and part of our database. Secondly, this sounds very neat, like time traveling. In reality, what this means is we're able to answer complex queries about state of our system at any given point in time. Fancy sentence once again. I'll try to illustrate with an example. We can easily tell from our event source, for example, how many customers used a particular product on December 2021. What this leads to, it allows us to easily compare states of our systems between two different periods in time, and then the business can be more business driven and make better decisions of what products survive and which ones should be euthanized. Okay, the third thing, doing event sourcing really encourages the team to actually discover the domain. As in, when all you're persisting is the changes, you need to understand these changes very well compared to just shuffling state on your objects. So it kind of tends to grow the amount of subject matter experts inside the team. Last thing, it's a bit HR related, but you can't deny the fact that most of the developers I've ever met in my career, they're various degrees of resume-driven developers, myself included. We like to work with cool stuff. We like to work with stuff we haven't worked on before. And at least at the time when we just started doing it, there were very few companies in Lithuania that were actually doing this. So it's objectively true that we used it to great benefit when hiring new employees. Yeah, but as I mentioned, there's no free lunch. And there are also some costs that are associated with running an event source system. First and foremost, your developers need to be upskilled in terms of using the pattern. Weirdly enough, this is more of a problem with experienced engineers than it is with graduates. Mostly because if you've already done CRUD systems for 10 years or so, it takes kind of a mindset shift to happen in order to be effective at working in event source system. I don't think it's a deal breaker by any means, but this is something you should probably take into account when doing onboarding for your engineers. Yeah, this one's my favorite. Refactoring is in fact very hard if you're using event source system, because in traditional system, all you have to take care of is that after your refactory, the end state still makes sense. In event source system, however, you also have to make sure that all the historical events make sense in the end system that you end up with. And depending on the size of your event source and unique types of events, it's an exponential problem. Finally, encouraging domain discovery, it's not always a good thing, especially if you try and apply event sourcing to an application that is too small and couldn't really justify using event sourcing for it, because it turns out encouraging domain discovery leads to a lot of discussions between engineers on how things should be named, like what's the correct name, is it changed or is it updated? I've had these discussions for weeks, and sometimes you would discuss something for 2 weeks, implement it in 2 days. Probably didn't make sense. Cool, so now we get to the interesting part. Where did we really screw up when we were doing this? I initially planned to have something similar to this slide, as in a nice title, some bullet points, right, and an image for the context. Turns out during 7 years we screwed up so many times that it's pretty hard to fit it in a single slide. So as a matter of fact, I kind of had to truncate a lot of stuff just to fit into the time frame. But I still kept the original slide because I think the image right here, it represents all of those mistakes to a very good degree. So all of these mistakes that we've made, right, they cost us time, eventually cost us money, but those were problems of our own making, and they are in no way part of event sourcing pattern itself, when we would rewrite our implementation, we would not be introducing them because, well, we already stepped on that plate once. Okay, this one's my favorite because it kept my family fed for almost 3 years. You have to put great care in how you model or what you model your event streams as. So during all of our examples, I have used so far user as a thing to be modeled by event stream, right? I would highly advise against that if you are actually doing event sourcing in production. And the main reason for this is, in our experience, entities modeled as event streams tend to become miniature black holes for attracting data. Back when I was a lowly team lead and just joined MobilePay, we had inherited something called a merchant. It was a microservice, I would say, as in it only contained a single stream with very little data. Merchant was something that represented a company MobilePay is doing business with, and it had very few properties. So business ID that could change, also contact details, as well as the name of the company. Sounds just like the user example, right? Turns out, as your business grows, the amount of processes that need to be automated and that are centered around these entities grows as well. So before we knew it, we had to actually do sanction list screening, we had to do onboarding, offboarding, beneficial ownership detection. It kind of spiraled out of control, I would say, since all of these processes actually were centered around the single entity of the merchant. What we ended up with is an event stream with more than 100 unique event types, and our microservice ballooned to nearly 90,000 lines of code. I don't think I need to go into much detail to tell what this meant in practice, but long story short, it was not scalable, the team couldn't handle it, it became a huge bottleneck, yada, yada, yada. So what you would naturally do, you would introduce new teams into the picture, right, so that you can vertically slice things. Turns out vertical slicing doesn't work that well if all of your code base in a single repository and all of your data is in a single database. What we did, and that's the actual part that fed me for a long time, is we started slow and painful refactory of event streams, and we remodeled most of our event streams to actually represent granular processes. So whereas we had merchant, from the merchant were born almost 15 smaller event streams, like sanction list screening, company details, know your customer, customer diligence, the list goes on. But the fact is that after stepping on this rig once, we have never done it again. And from there on, it's pretty much a standard to model event streams to represent processes. Okay, second of our screw up is dealing with the most fragile thing known to mankind, and that is an engineer's ego. Like every now and then, we will all make bugs, no matter how good we are, right? And some of these bugs will be severe enough to actually cause our business to enter invalid state. Natural reaction from me or any other engineer I know is make it disappear. So we would do our best to hide the body and make sure that the system looks as if whatever we did never happened. In case of event sourcing, that would mean either deleting an event in question or actually editing an event in order to change the data field. Sounds feasible, right? Myself in practice, I have taken parts and I think 4 journeys like that. And I've only seen it succeed once, and it took coordinated effort from 4 teams and a single week of time. In practice, it's almost always losing battle because of the fact that the events you are trying to remove might have already been projected. Furthermore, if you guys are actually doing event-driven as well, then it's very plausible that the event you're trying to remove might have already been distributed to other applications. From there on, butterfly effect kicks in, and just like posting your nude pics on the internet, it's pretty much impossible to stop it. It spreads too rapidly. So what we chose to do instead is we introduced something called the compensating event, which means that instead of actually trying to remove the event that wasn't supposed to happen, we would fire a second one that serves in order to undo the damage that the original event did. The developers have to swallow their pride, and the history lives on forever, but that's the only feasible way we found to sort this. Good. Let's move on to GDPR, right? I might have mentioned in the beginning of my presentation that MobilePay has been doing event sourcing for 7 years. Now, when I was preparing, I Googled a bit, and GDPR was introduced in 2018. What this means, it caught us with our proverbial pants down, and we were completely non-ready for their functional requirements, which meant that some of our data had to be removed, which is kind of hard to accomplish in a system whose core tenet is you never remove anything. In the end, form lost our function, and we ended up implementing functional requirement in the easiest way we knew how. What we did, we actually purged the entire event stream when the time comes. While it did work, I think it's something akin to killing a spider with a flamethrower, right? So it does the job, but it might cause collateral damage along the way. In case of MobilePay, that collateral damage was losing business insights on some of our processes. So just like 10 slides ago, I bragged bravely about MobilePay being able to tell how many customers each individual product used had at any point in time. Turns out, as soon as you start deleting that data, it's no longer available. Not a big secret. The good news is we haven't had that many cases of GDPR-related data termination yet, and we have a way to sort it, or a couple of ways. Currently, the one pattern that seems to be winning most sympathies from the engineers is cryptographic shredding. What that means is whenever we create a new event stream, we also create a unique encryption key associated with it, right? All the personal data that later on becomes part of that event stream would effectively be encrypted with the encryption key. When it's a time to bust out the flamethrower, what we do instead is we forget the encryption key we used. While the data is still there, it's effectively useless for 10 years maybe, until quantum computing happens, or whatever is the next big thing. Lastly, this is a bit cliche, but I think it applies very well to our journey. When all you have is a hammer, everything begins to look like a nail. So over 7 years, we perfected our application libraries to such an extent that it kind of became de facto standard for MobilePay, meaning whenever you would create a new application, no matter how big or large, no matter the domain, whether it's internal or public facing, you would use the libraries and you would spin up event sourcing. Yeah, while I like event sourcing, it still objectively is a more complex pattern, and there is decent amount of boilerplate associated with it. So we had some discussions, and currently we're at the conclusion that going forward in the future, we're going to apply it more on a case-by-case basis in order basically to save up on the time that we spent on the main discussions. All right, I think that kind of sums up all the content that I have. And if you guys have any questions, shoot.
But first, I will make some applause for Tomas.